In this tutorial, I'm going to show you how to find limits by using a factoring method. Alright, so here's our first problem. And up to this point in time, we have done limits like this by direct substitution. So let's go ahead and walk through that process just real quick. So if I were to plug in -3 for all of my x's, -3 squared is +9, and then plus x would become -3, and then I would bring down the -6. And then in the denominator I would have -3 plus 3. Now at this point in time, it really doesn't matter what I get for the numerator, although it will give me a 0. But more importantly, I have a 0 in the denominator, which is a problem because we cannot divide by 0. Anytime you have this situation, this is called indeterminate. I don't even know if that's going to fit here. It's just called indeterminate, and it means it's just mathematically impossible to do. So we can't use a direct substitution method. So we have to create a different way of getting around this. And one of those methods is to factor. And notice that the numerator over here is factorable. So I'm going to get my parentheses set up. And x squared is resulted by an x and an x, and I need factors of 6 that get me to 1, which is going to be +3 and -2. And then I'm going to bring down my denominator. I haven't changed him at all. Now, notice that something will cancel from the numerator and denominator. These x plus 3's are going to be gone. And so now all I'm left with is x minus 2. So we still have not gotten our answer for the limit yet. We have yet to plug in -3 again to see if we can actually get a real number. So at this point in time, I'm going to plug in -3 for x to see if I get an actual number as my answer. And sure enough, I do. -3 minus 2 is -5. And that would be my limit. So this is the method that we're going to use for the next couple problems. Alright, so what if you have a problem like this? Notice that if I were to plug in 1 for the x's in the denominator, I would have 1 minus 1 plus 1 minus 1, and that would once again give me 0, and we don't want that. Also in the numerator, I would have 1 minus 1, and that gives me 0 again as well. So we have to use factoring again, and in this case we have to use a little bit more of a clever technique to factor this denominator. This isn't a nice perfect cube type of situation. So what we're going to do is bring down the numerator, and similar to the factoring skills that we have learned, we are going to do this by grouping to see if it will help. So what that means is I'm going to group together the first 2 terms, and then I'm going to group together the second 2 terms. And I'm going to see if I can pull out anything in common that they may have. So between x cubed and x squared, I can actually take out an x squared. So I'm going to do x squared and then parentheses, and I'm going to figure out what I need inside these parentheses to get x cubed minus x squared back. So x squared times what gives me x cubed? The answer is x. X squared times what gives me -x squared? That's -1. If you're unsure about your factoring skills, distribute him and see if you get x cubed minus x squared back. That should be a pretty good indicator if you know what you're doing. And now I'm going to bring the plus sign down, and between x minus 1, the only thing common between x and a -1 is a 1. So I'm just going to write him down. Alright, now notice at this time I have 2 binomials that are identical. This is what I'm looking for. This is what's going to be helpful, because let me show you how I can rewrite this now. My numerator stays the same. In the denominator, I'm going to have 2 binomials. one of those binomials is going to be the one that was identical, so x minus 1. The other binomial is going to be created by whatever was left over, which is x squared and then plus 1. Now hopefully what this will do is help me cancel something out. And sure enough it does. The x minus 1's are gone. I need a 1 in the numerator as a placeholder, and then x squared plus 1. So now what we want to do is we want to try to plug 1 in again and see if we can get a real number. So that would be 1 over 1 squared plus 1. And 1 squared is 1, plus 1 is 2. And sure enough, there you go. There is my numerical answer for my limit. We have one more problem to look at, and then we're going to wrap up. All right, last but not least. In this case, we have a fraction where, once again, if I plug in 6, I have an indeterminate form. I have 0 over 0. So we can't factor the numerator because it's just x minus 6. But the denominator is factorable. The denominator is a special case of difference of perfect squares. So difference of perfect squares is always factored by 2 pairs of parentheses and an x here, because that is the square root of x squared. One of these gets a plus, one gets a minus, it does not matter the order. And then the square root of 36, which is 6, goes here and here. Sure enough, the x minus 6's cancel. And now I'm left with 1 over x plus 6. Let's try to plug in 6 again, because that's what I'm approaching, that's what my limit is going towards, to see if I get a numerical answer. And I'm going to have 1 divided by 6 plus 6. So sure enough, this is going to give me a numerical answer. I don't have 0 in the denominator anymore. And my answer is going to be 1/12. So there you go. That's how you do limits by factoring, and that will conclude this tutorial.